And hello and bonjour à toutes et à tous. My name is Sandhya and I'm the Executive Director of the Royal Astronomical Society of Canada. And it is a great pleasure for me to welcome all of you to the return of our Lunch and Learn series. I am over the moon for today's session on citizen science lunar eclipse observations. Before we go any further, I'd like to recognize the land on which I am located today, which is the traditional lands of the Mississaugas of the Credit, the Wendat, and the Anishinaabe peoples, and is today the home of many other Indigenous and First Nations peoples. You're all tuning in from various places across the country, and I encourage you all to also learn more about those traditional lands and the First Nations, Métis, and Inuit peoples who may live there. So today's session is hosted by Allan McCue from the Calgary RASC Centre and Randy Enkin, past president of the Victoria RASC Centre, with an introduction from Kirsten Vanstone from the Toronto Centre, and they will be guiding us all through the steps to contribute to the data collection on the exciting upcoming lunar eclipse. So feel free to everyone to follow us on YouTube, subscribe to our newsletter to find out more about our Lunch and Learn series. But for now, I will turn things over to Kirsten, who is up first.
Excellent. Thank you very much, Sandhya. Welcome. Thanks everybody for coming out today. It's great to have so many people. I hope the timing works out for all of you. We tried to kind of make this work for most of the country. We have two experts here today to give us tools to help us with an observation that I have personally never made. I have seen a few lunar eclipses in my day. I have tried to do the darkness, the Danjon scale measurements before, never too seriously, but I have never actually tried to do what we are going to be talking about today, which is to use timings of the shadow as it comes across the moon and then leaves the moon on specific features on the surface. If you were at the GA, we did a little session about this in preparation for what is one of the sort of rarities, which is a lunar eclipse that happens in the summertime when people actually have time to go out and observe. And it happens, fortunately, in August, which means it's not getting dark at 11 o'clock at night. So you can actually see the thing. And people are paying attention to the sky. I got an email from my boss today saying, "Oh, I saw some meteors the other night." He's not an astronomer. So people are spending a lot of time looking up at the sky. Lunar eclipses, I mean, many of you have probably seen them. They're not necessarily, I don't know, people may not consider them to be super special or perhaps not opportunities to do real observations, but in fact, they are. And the more I read into this and talked with Randy about this, there are some mysteries around lunar eclipses that these observations that you're going to learn about how to do today can possibly help solve. Not sure, but the more data we get, the more we have to work with. So I just want to give a couple of housekeeping things before we get deep into the program. We're going to run hopefully until 2 o'clock today. We would love for you to interact with us. So I want to shout out to Kevin Kell from Kingston Centre, who's been sharing jokes in the chat. If you were here, you can scroll up and read them. If not, maybe we should include them with the materials for this event because they're very good. I think I need to get out to a Kingston Centre meeting if that's what they're like. But also, please do interact. If you have something you'd like to say, put it in the chat. I will be monitoring that and passing along comments to Randy and Allan. And if you have questions, similarly, please put them in the chat. And if it makes sense, I will interrupt the flow of the presentation to ask the question. So we want to make sure that you're, engaged and not, I used to work in a planetarium, so it's quite often that people would fall asleep during presentations, but we're not going to do that today. So it's going to be lots of fun, and our chairs are not as comfortable. So with that, may I turn it over to, I guess it's, are we going to?
I go first.
Randy
I go first.
Right. Yep. Thanks very much. Over to you.
Here we go. I share, and just want confirmation. We're basing this talk on the talk that I gave with Kirsten at the General Assembly. And come on, are we going to move? There we go. There we go. Why is lunar eclipse crater timing important. And whereas we have GPS to tell us where we are, and long before that we have really accurate clocks, let's put ourselves back a couple hundred years. And if you're on a ship and you have to know your latitude, you can just look at the elevation of the sun, and it's a direct measurement. Very, very easy to figure out your latitude. Longitude, though, is dependent on knowing the time. And the thing is, if you do not have an accurate clock, you're going to have to reset it every once in a while. And the way that you do that is by looking at something astronomical. One of the classic ones that worked really well was looking at the Jovian moons, the moons going around Jupiter, and the exact time of their going behind the planet was something that you could do if you had a good telescope and a stable platform. But what's very easy to see, anywhere where the moon is visible during an eclipse, is the time that the shadow of the Earth goes across a particular crater. Okay? Makes perfect sense. If I know my local time, where's the sun across the sky, and what the time is in Greenwich at the prime meridian, then I can work out what my longitude is. It was a huge problem. It was the big science of the day. David Sobel's book on longitude describes it very well. So let's talk a bit about the system of the sun, earth, and moon. I just got this wonderful Lego orrery, and here we are. That's full moon when the moon's behind the earth. There's new moon, full moon, new moon. You see how we have this dance of the sun, earth, and moon. Now, when the moon is between the sun and the earth, we call that a new moon, because the far side of the moon is what's illuminated and the close side is in shadow. When the moon is on the far side of the earth, that's a full moon, where it's the whole phase pointing towards the earth is illuminated. But you see that the moon is not going around the earth in the same plane as the earth is going around the sun. So in fact, there are 2 eclipse seasons every year. Okay, so normally at a new moon, you get the moon's shadow going above the earth or below the earth, north or south of the earth's rotation. But when we're on what's called the line of nodes, and this year it was in March, and it is now in August, we get our solar eclipses and lunar eclipses. So on August 12th, I was in Montreal, and I thought it would be fun to have this dance of the earth, moon, sun, and the biosphere. So here we have the conjunction of spheres in Montreal just a couple of weeks ago. I was very pleased with taking this photo. Anyway, that is when the moon is getting between the sun and the earth. But next Thursday night, the moon will have gone 180 degrees around the earth, and the earth is going to put the moon in shadow. And it's really very good for all of the Americas. It's not a total lunar eclipse. It's what you would call a deep partial. It's 95% or something like that. But for this purpose, there's no difference. It will do everything that we want. And what you see here is in Eastern North America, people will see the entire eclipse in the evening going into the 28th, the early hours. But you'll be able to see everything in Eastern Canada. Where I live in Victoria, the moon is going to rise in eclipse. It's going to come up red, and it will then, between 8:30 and 10:30, we will see the the moon coming out of shadow behind the Earth, and it will get more and more illuminated. Now, it doesn't happen that often. We only see a total or deep lunar eclipse about once every 2 years. And coming in the summer evening, it's really been very grim. It happened in 2015. So, and that's only if you count September 28 is still summer. It's summer-ish. And then we're going to see it again in 2029. But it's not that common an event. And so that's why we're really pushing for this to be a pan-Canadian, maybe pan-North American event for people to make these observations. It's one of the few cases when we can do it. So just to get our terminology correct, the sun is not just a point. It's a half a degree across. And so when the one limb of the moon is still showing behind the Earth, then we have what's called penumbra, okay? So there's still some of the sunlight getting to the moon. But when the whole sun is obscured by the Earth, then we are in umbra, which is just Latin for shadow. So I find these pictures are kind of non-intuitive, but this is very intuitive. So this is just, 100 meters from where I live in Victoria, and this mountain, Glacier Peak, is 170 kilometers away. And you see over this 12 seconds between these two photos, the sun came out from behind the mountain. So this is what we would call penumbra. If you see the whole sun, then you're in full illumination. But when there's just a little bit of the sun, then that's the almost shadow, the penumbra. And then when the sun is completely missing, then we call that umbra. There's still light because we have atmosphere and the light gets diffracted around that. But this is exactly the same thing that's happening, but instead of 170 kilometers, we're 400,000 kilometers away. Now, what are the stages of a lunar eclipse? My astro buddy Joe Carr took these pictures. We had a beautiful clear sky in January 2019. It was a remarkable, remarkable eclipse. You don't plan on a big observing campaign to watch the eclipse in winter because we have so many cloudy nights. But this one happened to be good. And so here you see the moon is still fully illuminated, okay? But then as we go along, then they go into the Earth's shadow, and then Joe completely changed the exposure because a camera just doesn't have the dynamic range to see the umbra and penumbra at the same time. It saturates, okay? So this is really a naked eye observation that we're trying to do. The cameras are just no substitute for what we can do with our eye when it comes to trying to figure out this sort of timing issue. Okay, so let's just take a look at these two pictures. And Tycho is just one of those craters that's easy to see. It's lovely because there are these ejecta rays all the way around. And so even if you can't see Tycho, you know where it is. And so here it is in umbra, but you still know where it is because you have these rays. So Tycho is one of the great craters to do the eclipse timing with. And so here you go from full illumination to the penumbra. But at some point, the umbra creeps across the moon, And the game is, if you were at sea, could you set your clock to the time that you transition from penumbra to umbra? It's not a snap in time. There's actually going to be an interval. In my observations, I can convince myself I'm good to plus or minus 10 seconds. Sky and Telescope asks you to say the time to 6 seconds. I don't know where that comes from, a tenth of a minute. Anyway, here's the issue. For over 300 years, it's been known that if you know where the sun and the earth and the moon are and how big they are, then you can predict what the size of the Earth's umbra is going to be. And it turns out to be about 100 kilometers larger than you would predict based on the solid Earth. And it's often considered to be that the atmosphere is part of the issue, why the Earth appears to be bigger, the Earth's shadow appears to be bigger than you would expect. Anyway, this has been a problem for over 300 years, and especially Roger Sinnott at Sky and Telescope has been compiling data, and it's that exact thing that we're trying to add to Roger Sinnott's Sky and Telescope compilation that we're going to try to add to next Thursday. So some practical issues. Well, Sinnott is very helpful. Every eclipse, he puts out a list of the expected ingress and egress, or entry and exit times, of various craters across the face of the moon. But I don't find that very handy. And so I have taken an image of the moon and I put the times right on it. So here's Tycho with its lovely ejecta that point right to it. And in Eastern time, we expect it to be at 22:57. It's going to go into shadow, and at 1:29 in the morning, it's going to come out, for example. And so you set up, here I am in front of my house, and there's a street light. That doesn't matter. The clouds matter, but you see there's a hole here. And so my astro buddy Kevin Bertels and I are able to do some measurements when this hole in the clouds reveals the moon. We didn't get to see the whole thing, but it doesn't take big equipment. Here I'm using a 6-inch Newtonian, and Kevin's using a 3-inch Maksutov, and those are perfect. You want to be between 50 and 100 times magnification, so you can really identify the individual craters, but you don't want to focus in too close because then you don't get the context. And then you put on an audible clock. So I just want to tell you, the one that I use is called ticking clock. This is what it sounds like.
20 minutes.
So every 10 seconds, it tells you what time it is.
Ten seconds.
Anyway, you get the trick. So that's going on. And the two of us would say, okay, let's look for Plato now. And we'll look at the map and make sure we knowing where we're looking. And the two of us will discuss it. Is it there yet? No, not yet, not yet. Oh, okay. And then we write it down. So we actually wrote right on the map. We didn't give the hour. We just gave the minutes and seconds. And you see, we kind of gave times only to the 5 seconds. And you'll also see for Plato, we gave 3 measurements, each a minute apart. That was for when it's called first contact, when the umbra first hit this large crater, and then in the middle, and then the end. And we saw that it was about 2 minutes for the umbra to get across the diameter of Plato. Anyway, it's handy to know your moon position locations, but you know, only do the really bright ones. And if you only do a couple, that's still wonderful. The ones that get a lot of observations are like Tycho, Copernicus. Those are the two big ones, but Plato is another really good one. So the thing is to pay attention and say which one is coming up, and then it's better to do it 2 people. I would think more than 5 people might be a problem. 1 person, it would be a bit lonely, but you can do it alone, no problem. And then lovely Kirsten has made a form. If you just want to write it on a piece of paper and take a picture and send it to me, that would be just fine. But we can get people to put it in this form. You can get it, take a picture of this funny picture, and it'll take you right there. And we're putting it in the chat, and we'll give you lots of ways to find this form. And so what is it that we're trying to get you to do? You want to have magnification that will allow you to see the context and not be too detailed. And also we want it to be something like what it would be like for a 19th century amateur astronomer. Okay, like what would you do with the equipment at the time? And so, 30 to 100 times on an untracked telescope is just perfect. I find having an audio clock very handy. Doesn't have to happen, especially if more than 1 person, but that's one way to go. Print out a copy of the lunar map. We'll make these available in the chat and in emails. And you write down the numbers, and then you can either email me or you could submit to this website. And I think that's where I'm stopping.
Randy, could you put the QR code back up?
You
I
bet.
finally got my camera going, so I can take a picture of it.
Just to be
You know
clear,
what? We'll put it in the chat. We'll put it in the chat.
We'll revisit the form in a few minutes. And I will put it in the chat. I don't actually have the tiny URL version of it, so it's just going to be the full thing. Sorry, everybody.
I'll work on that. Well,
but
there's to his presentation.
Yeah, well, we can bring it up at the end again too, and just show it, because that's where the results go.
Maybe it's worth just pausing to see if there's any questions. So all straightforward. And if you haven't read Longitude by Davis Obel, highly recommend. Lori.
I agree. Good book.
Lori?
Hi. Randy, can this be done with binoculars?
Oh, yeah.
Okay.
Yeah. I would think if you can see the individual craters, then you can do these observations.
Right. So a little bit of maybe a bigger set of binoculars, but you can still do this.
No,
I think.
10 by 30s would do it.
Yeah. Yeah. Okay. Great.
Okay. Matthew.
10 by 30? No. What do you?
Yeah, I think I know the
17
answer
by
to
50s, 10 by 30s.
Oh, sorry, we're still on binoculars, Matthew. Hold on.
Nah, no worries. I think I know the answer to this, but what would prevent us from setting up, say, a C star with some sort of, time coordination and actually just reviewing
dynamic range?
That's what I thought.
It's perfectly valid, and it would be very interesting to compare. But typically, you're either going to set it up to be too saturated during the penumbra, or it will be too dark during the umbra. The human eye and the brain that attached to it is just fantastic. It's amazing, and there's no there's no way to do that. Actually, I'm going to say a way that I'm very interested in is professional observatories have been very interested in looking at the spectra of the light going through the Earth's atmosphere and onto the moon during an eclipse, because that is an analog for what the Webb telescope is doing, looking for the exoplanet atmospheres, looking at these eclipsing exoplanet spectra. Anyway, there are a couple of articles that I've seen so far that have used the moon as a mirror and have been looking at that. And when you take a look at their total brightness curves, then they have the dynamic range to actually compare to these motions. So that's an interesting thing.
Who would have thought going from, looking at the moon for an eclipse would get you to that kind of science? Sorry, Alan.
It's just great.
Yeah. Well, I was going to say exactly the same thing. It's the analog, but to be able to extrapolate that and use it for the search for atmospheres around exoplanets, that's real science we're doing here.
Yeah,
absolutely.
It's amazing.
Jackpot. Amazing.
It would be interesting if you have a C star. It'd be interesting to just try it. You never know, right?
And put the timings in. Just make a note saying that these are from the recording using an electronic sensor, and it's not a C star. It could be any camera,
anything,
any movie. And I'd be very interested to see how it relates. For the purpose of this game, which is trying to figure out whether people 200 years ago could use this method to set their clocks more accurately, then no, it's not the same thing. But I love the idea of, what is the difference between the naked eye and the instrumented eye? That's an awesome research project.
Mm-hmm. Very much so. Okay, anybody else? Okay. Oh, Sunny. Yep, go ahead. Hello.
Yeah, sorry. In the speech that you just gave, you mentioned that we should use untracked telescopes, but why can't we use tracking telescopes?
Use a tracking telescope. I'm saying you don't need to.
Oh, all right, my bad.
If you don't have one.
Tracking makes it easier. It's wonderful.
Yeah, that's what I was thinking.
Yeah.
All right, thanks.
Much easier, I'm sure. That's a good
thanks
question.
For asking the question. Yeah.
My 6-inch Newtonian, I have put on a C8 wedge, so it actually tracks. It's a bit of a Franken telescope.
Best kind. Okay. Thank you, Sunny. All right, let's move on. So, Alan, you're going to take us through an electronic tool that many of you are familiar with, but how you can apply it to this project.
To do some session planning. Okay, let me share my screen. And where the heck is it running? It's not running. So we're going to fix that. I've just got up to the raw presentation. So now I see the screen. Let me get back to Zoom. Me and Zoom, like I love to say, don't always get along. Where did that go?
We need a joke, Kevin.
Yeah, exactly. We need a Zoom joke.
I think I just posted
there's
that.
the share button.
15-page form. It's only okay. We'll go to there, Kevin. Kevin's worried that the form is too long. It's just because we have an opportunity if you really want to make lots of observations. So there's lots of each page. I made it kind of discreet.
There's the Zoom. Okay.
You got it? And Alan, there's another question that I think I can answer. Georgia asks if wanted to, it only gets one of the timings. The ingress or the egress. Yeah. Any timing is good timing. Any data is good data, right?
Absolutely. We're only going to see egress out on the West Coast.
Yep. And to Ryan, yes, I believe. Oh, thanks. Sandhya has already answered that. This will be uploaded to YouTube. Allan, have you got it?
I think so.
Looks
Let me
like
know
it.
It says core stellarium for lunar eclipses, stellarium training series.
It's saying it's started screen sharing, but I don't see any content yet.
Oh. It says I am screen sharing.
There you go.
Yes.
There we go.
Hooray! We do have the technology, and we've a instructor that can figure it out. There you go. So I changed my name on the display to Allan.
Uh-oh. I think Allan froze.
Oh no. Okay, Kirsten.
Okay, I'm going to just show people the form while Allan does this. Okay, so the form, there are many of you out here who will probably be much better at designing these forms than I am, but we put this together based on some good examples, I hope. So is everybody seeing something that says RASC Citizen Science Lunar Eclipse form?
Yes.
Good, and not my work email. Excellent. Okay, so the first thing we'd like is to be able to, you don't want to watch my work, it's very dull. We'd like to know who you are, so we'd ask that you please provide your name and email address. This is not my email address, but I would love it to be my email address. Nor is that my name, but just I was having fun. I am at Toronto Centre. Date of the observations for me would be the August 27th, so it's year, month, day. It will allow you to select from a calendar. And your time zone, hopefully you know your time zone. If you're observing from a time zone that we haven't included, maybe you're coming from somewhere quite different. I don't know. I tried to include all of them. Where are you observing from? This is really important. As it happens,
actually,
it's not that important.
For the observations, it's not at all important.
Oh.
This is out of curiosity.
Okay, well, that's fine. So I put it in here too because I am sitting about 200 paces away from a marker at the University of Toronto, which marks the spot of the transit telescope where Sanford Fleming marked the latitude and longitude of Toronto and then measured the rest of the country from it. So I'm going to tell you that that is our latitude and longitude, minus for west, plus for north. If you happen to be somewhere else, flip them over. I have a 6-inch job that I would probably use if I could collimate it before this event happens. Turns out I'm going to be in Halifax, but maybe I'll bring my binoculars, and who knows? Okay. Then we get to the meat. So we decided to include some of the events that you could see in an eclipse as the shadow goes across the moon. These different types of events are labeled 1 to 9, and Randy helpfully made a little chart that show the relevant ones. If you want, you can name, give your time of when you think the partial eclipse begins, the total eclipse begins. Those are elements 0 and 4. But the ones that you're likely to be looking at are 1, which is first contact between the shadow and the object, and then the midpoint, and then when the shadow leaves the object. So, and there's also, if the object is big enough, you might have item 6, which is when the shadow begins to leave the object, and the midpoint of the shadow leaving the object. So, if you're just doing this as your first observation, you probably just want to go with enters the object, midpoint of the object, leaves the object, or indeed, as Georgia asked, enters the object. Any timing you can get. So
basically, hold on. No.
Yep.
Most people are going to do 2 and 7.
But that is fair. Yeah, 7. The midpoint. Yes. So depending on how big the object is, you're probably just going to say, oh, the shadow hit the thing. I'm going to call that the midpoint. Especially if you're picking sort of a visible crater like Tycho. So then you have a feature. So we suggested a list of features. These are the ones that Roger Sinnott provided. So they're in alphabetical order. We talked about Tycho earlier, so we can just select Tycho. If you want to go with another feature, Fine, just label it. And then what event are you actually timing? So we figure it's probably the midpoint of the shadow, most likely. And then the time in the format of hours, minutes, seconds. And then if you want to add another observation, click yes. So I don't suggest that you do this form while you're observing. You probably just want to write it down. It'll be faster, or even dictate it into a voice recorder. That might be even better. And then you go in and do this after. If you want to add another observation that you made, just go next, yes, next, and do another one. And this time I'll do Copernicus and egress and time. And then I say I want to do another one. Oh, I got so good. I did so many. I will choose, Grimaldi. And this is the egress of the shadow, whatever event it is. And then your time. And you have to put in a time. So I will say 23, I don't know, 14:55, whatever. And then finally, that will be my last observation. So I will say no more observations. And then it'll say, great, thank you for observing, and leave your comments. This was fun. This was dumb. I don't know why I'm doing this, whatever. Please do more. Give us more stuff. We love the Lunch and Learn, whatever you want, and then submit it. Okay? Sorry, I just want to acknowledge that Allan is back. And Allan, we just decided to go ahead with my part while you got yourself sorted out. It's okay. So the form is pretty straightforward, but as you note, if you're doing this for the first time, just probably an email with the timing and the object would be good enough for Randy. If you want to use the form, it's here. And it was not created in vain. Okay. So I'm going to stop sharing. Are there any questions about the form? Okay. Okay. There it is. All right, Allan, back over to you.
I think I am ready to start sharing again. I just got permitted to do a multiple share while you were exiting out. And I always have to remember in Zoom to hit the share button at the bottom, because I'll start talking and our screen won't get. So
there you
are good. Sharing. We're good to go.
You're good.
We got thumbs up from people. They're seeing things. Excellent. And hopefully we'll be on longer than 10 seconds. Here we go. So I'm the Stellarium guy. I teach the Stellarium Introductory Level 1 course and have been doing it since I got recruited by Blake Nancaro back in the dark days of COVID in 2020. God rest his soul, may he rest in peace. He was a fabulous astronomer and truly believed in a lot of the things in the association, from the running the observing program and starting the teaching program. Fabulous guy to work with, and a great mentor to me. Anyways, I teach level 1 now and have been doing that for a number of years. We're ready to start that up in September. So if you haven't gone through the training, it's free and we'd love to see you in there. We've kind of standardized on this tool. There's a few reasons, like you could use Sky Safari or Starry Nights or different programs, but Stellarium is free. It's extendable. It runs on multiple platforms, and it's just a great program that I found. It's not perfect. There are some limitations, but what we're going to do is show you how you can use it for planning the sessions. To take a look, fast forward as to how the eclipse is going to progress. How's it going to cross the screen? If you looked at Randy's map from his presentation, I made a note in the chat to say this has been flipped, because Tycho was up at the top as opposed to down at the bottom. So I'll show you how to flip that so it matches the optics on your telescope and from your viewing situation, whether you're using binoculars or Newtonian or a Celestron Schmidt-Cassegrain like I've got going here. Anyways, enough talk about that. Let's keep going. Page down. And why are you not paging down? Oh, I hate it when this happens. Let's go back to the other half of the PowerPoint. And we'll see if we can bring it. First order of business. Is this one showing up on the screen?
We are seeing the Stellarium training series. It looks like your home screen.
Why is that not going forward? Page 10. There we go. First order of business. Thanks to Sandhya for setting the Zoom session up. Thanks for other presentation presenters. especially while I was having my Zoom issues. The goal for this one is to show you how Stellarium can be useful as a session planning tool. And one more thing, first order of business, very important. Happy birthday, Sandhya. Today's birthday. And thank you for being with us today over our Lunch and Learn and not being out celebrating a birthday lunch with your friends.
My pleasure.
So everyone should say
There's
happy
still
birthday.
time. I'm just down the street.
There's still time. Okay, so agenda, setting your location, setting the time, turning on the umbra and penumbral rings. The first two are really basic and should be familiar to everyone that's working with Stellarium. But turning on the umbra and penumbra rings, showing where the shadow is something that I learned from Chris Vaughn when he was doing his Lunch and Learns back on the COVID side. And I went, ooh, that's very cool. We'll take a look at how the lunar eclipse progresses across the disk of the moon, show where it's coming on in its normal view, and then show when it's coming on in its flip view or inverted view. So you can get a feel for how this is going to progress across the surface. And we'll do it at fast forward speed so that you don't have to wait the full hour and a half to figure out where it's going. You can plan what craters you want to take a look at from the list that Randy's put together. We're going to look at a specific event using Plato as an example. At the General Assembly, we talked a lot about Plato and the crater timing for that. So we've got a couple of screen prints from there. How to use the flip buttons to mimic your telescope view. And if time allows, this is something that I think is extra cool that I learned from Blake, is how to view the eclipse from the moon's surface. So you position yourself on the moon at Tycho, and then you can watch the Earth progress across the disk of the sun. And you're going, that's pretty cool. So if you were an astronaut, that's the view you would see. Don't need to talk about this map. Randy already went through that in his presentation. So first of all, you'd set your location. Now we're going to look at these here, and then we'll bring up Stellarium, and then we'll show you how to do these things. So where the buttons are, which buttons you have to click, all those kinds of things. So first thing we'd go in and we'd search for Toronto out of the list. It brings it up. It automatically sets the lat, long, and elevation for you. It sets the city, and then you can use that as your current location or wherever you're going to be. So if Kirsten said she was going to be out in Halifax, that could be the location. Or I'm in Foothills, I'm going to put in my exact location and bring that back in. Page down. Roll. Turning on the umbra penumbra rings. What you need to do is go to the sky and viewing tab or button on the side, which is this button here. And that can be accessed by a function key, F4. And then you want to go to the markings tab in the middle, and down at the bottom of the third column, there is a button to turn on the Earth umbra and the Earth's penumbra. So that's in column 3. You're going to turn those on, and that's going to give you a set of concentric circles for where the umbra and penumbra are projecting out into space. So again, you remember the Earth's umbra is when you're in full eclipse. The Earth penumbra is when it's in partial eclipse. You're going to set the time of the eclipse. So we're going to set it to 2026, August the 27th. So we're going out the evening of the 27th, 28th, and about 2300 hours Eastern Daylight Time. It should be EDT, not standard time, but EDT. And that's going to be kind of full eclipse underway. And we can then move forward and backward time to get that umbral shadow over the desired crater. So you'll have an idea as to what's there. Now, just like Randy was saying, is that the dynamic viewing and dynamic range of the eye, it's so much better than what you get out of the software program. On the software program, the umbra penumbral line is not a nice crisp line. It's a little bit wide. So this is more useful as a planning session than as a total, this is exactly when it's going to be hitting that crater, because you just can't make that assumption. So once you've set the time, we've got it down here, 8:27 at 2300. You can see these two concentric rings for the umbra and penumbra, and we went out to find the moon, or you can turn on the ecliptic and then look into the southeast portion of the sky and zoom in. The moon will touch the moon's eastern limb at approximately 2300 hours Atlantic Daylight Time. So, Kirsten, you were wondering when to go outside and look up. That's when you would do that. Eastern Time for those in Ontario and Quebec, 22:33. You get the idea. And as Randy loves to say, out in Victoria, it's going to be perfect because the moon will be rising just as the sun is setting, and you can watch it progress from a nice early hour. In the east, it's going to be a little bit later, but you're still going to get that good view. And again, why are the minutes exactly the same? Because this is happening, at a universal time. The event is actually starting, and it's just the time zones that are different. So the hours are different, but generally the minutes and seconds are the same. So after I zoom in, here you can see the circle with the umbra, and as the eclipse is progressing, and then I've got the penumbra on the outside. So if we start to play this fast forward, you'll see the moon come in, or the penumbra go out and reach and touch the moon. So exactly when it's on that limb, when it's first contact with the disk, and then you can plan based on your map of the moon's craters. So on Stellarium, there's an option to turn on the nomenclature so that you can see what craters you're looking for. So for example, if you go Alt-N or Option-N on a Mac, so Alt-N on a PC or Option-N on a Mac, got those two keys down here. I always love to call this the Starship Enterprise key. I don't know what it's called or what it looks like, but that could be pretty much the Starship Enterprise. So you go Starship Enterprise, Option-N on the Mac, will turn on these green names. And as you zoom in, you'll see the various crater names. So for example, you don't see Tycho down here at the bottom as a name until you really zoom in, or Plato up at the top, which is what we're looking at up here. But as you zoom in, you will see those crater names, and we'll demonstrate that and we'll show it. So as you zoom in, you get more craters as per the Randy's timing sheets. So you're going to turn on the nomenclature data. I think we might have a duplicate slide in here. So zoom in, pick your crater. Here's Plato. And what Stellarium predicts up on the screen here is that it's going to make first contact on the umbra, on the entry into Plato crater at 23 hours, 44 minutes, 42 seconds. Again, Eastern Time. If that's not the view that you're seeing in your telescope, you can use the flip buttons, and you may not see them on your screen unless you turn them on. So the first thing you have to do is go to the configuration tab, hit extras, then you click flip buttons on, and then it creates two buttons at the bottom of your horizontal menu that allows you to flip it so that you can get the view that you're seeing through your telescope or binoculars. Of course, with binoculars, no flip is needed, right? What you see through your binocs is what you're going to see with the naked eye. With a Newtonian, you're going to need a vertical flip so that it looks just like Randy's map. And with a Schmidt-Cassegrain using a star diagonal, which is my setup, you're going to need to use both the vertical and the horizontal flips. Reality is that whatever telescope you've got, if you're using one, based on the direction that you're seeing the umbra progress across the moon, whether it's going up, whether it's going down, whether it's going left or right, you can use the flip buttons to mimic exactly what you're seeing in your. So this is the flips based on my Schmidt-Cassegrain. So 2 slides ago, we saw this Plato being, this is what you would see through a set of binoculars or with your just unaided eye. But if we look through the telescope, we're going to see this flipped, and we're going to see the eclipse progress across the phase kind of in this motion, downward and to the left. I should pause for air at some point. Any questions up to this point?
Al, would the SCT have both the horizontal and vertical flip?
Well, it depends if you're using that star diagonal too. And I don't know. Sometimes I have it in, sometimes I have it out. I would, you may be correct on that. I may stand corrected. It may be just the single flip for the horizontal.
Yeah.
Check against what you're seeing through your eyepiece.
I'll have to take it out and test it.
Yep, absolutely. Actual conditions may vary. And down at the bottom is where those flip buttons show up. If you're not seeing the horizontal flip and the vertical flip with these arrows going in opposite directions, then that's where you need to go back and run the configuration and turn them on. Okay, by hitting this under the configuration extras menu item, then that makes them appear down at the bottom. iPhone timing app. I couldn't find ticking clock in the iPhone store, so I'm saying it's available for Android users only. If anyone has a good observing app that calls out the time, I would love to know it. I've tried out a number of different apps, and they will call out on the hour, or they will call out on the, the quarter hours, but they don't go down to the nearest 5 or 10 seconds. The app that I use on my phone when I'm observing is this timing app called Time, and it's by Emerald Sequoia. For whatever reason on the picture, it lobbed off the bottom down here. But while it doesn't talk, it shows a really precise internet time, goes out to a number of different servers, and then you can see slightly different times here, averages them out and says, this is what your time is. And it has an option to do a red light viewing on the bottom left-hand corner. There's a red moon. You click on that, it turns your screen to red for nighttime viewing. So this is the one that I use. If I see something in the scope, I will then take my eye away from a second, just look over and see on the iPhone what it is, and then write it down on the map. And speaking of maps, if you're not great with moon craters, one thing that is very handy to look at is this thing, your observer's handbook. And on page number, I have this one in on the reference, but on page number 148 and 149 is a beautiful map of all the named craters. And that allows you to do your planning again based on the timings. You get that out of the Sky and Telescope or off of Randy's maps. And then you can say, okay, I want to look at it at Kepler. I want to look at it Copernicus. I want to look at it Grimaldi, look at it at Plato, and then plan out what you want to observe, and then track it on Stellarium, see how the eclipse and the umbra is going to approach those various craters. So that's a wrap on the slideshow. Let's take a look in Stellarium. Let's just get one more page down here. So final questions before we go into bringing up Stellarium. So thanks for your time and participation. This presentation will be saved on YouTube. If you haven't done a Stellarium course, classes again will start up in September. There's one going to be on September 9th. Watch the RASC weekly newsletter for times and dates. There'll be another one about 3 weeks later, near the full moon. We like to do the evening courses in the full moon. The one on the 9th of September is going to be an afternoon course. What else can we say here? Any questions? And then I'll just bring up Stellarium and we'll share that.
And Al, we have 6 minutes left.
Okay, this will be quick because we've already done the other stuff.
Yeah.
6 minutes. So I need to stop sharing and then reshare.
Okay, why don't you do that? I'm just acknowledging there's some good comments in the chat. ALPO's website, ALPO recommends time.gov, Association of Lunar and Planetary Observers. If you don't know what ALPO, it's not the dog food. It's I'm showing my age.
Good one. You were looking for yeah.
Time.gov also told me that my laptop's clock is wrong, which is interesting. So there's that. If you have access to it, it's a great resource. It is shows the US. I don't know if it's possible to get the equivalents, but it is the Central Daylight Time, Eastern Daylight Time, like that. Even though it's showing the US map, it's pretty easy to figure it out.
So, a needle pulling thread. I just want to go back to the time here. so we set our location. We said that was the first thing you had to do. We're going to set the location here. And I'm going to take zoom off of that page and move you guys over to it. Okay. And the next thing we said we would do. So let's go back to location. We're going to pick on Toronto. This is the list. If you want, you go into the search button here, type in Toronto. It says Toronto, North America. You can see the red arrow here positions you on Lake Ontario. You click on it and that gets you to your location. Whatever location you are, if you want to know the exact location, if it's not on a city, again, Kirsten had hers from the university. I can put in my backyard. You just look in Google Maps and that'll give you the lat long, right? If it says save location, it'll give you your lat long. So that was the first thing. Second thing is to set the time. We said we want to go to the 27th and about 23:44. So I'm going to change the date to 23, and then I'm just going to highlight that and make that 44 minutes. Okay, next thing was to turn on the umbra and penumbra lines. So I'm going to my sky and viewing options, and then to markings. And then we've got the umbra and penumbra over in the bottom right-hand side here. We turn those on, and that creates those two concentric circles. So now I can go find the moon. I go to my search button and I'm looking for the moon because I don't see a moon on the screen there. Let's remember it. And these are those two lines, and you can see we're already mid eclipse going on here. Okay. And I've got this crosshair in the middle because this is the dead center of the umbra. And I can zoom in by using the wheel on my mouse. And I can back that up a little bit, right? So let's back it up an hour or two. So I'm going to go back up to the clock. Whoops. And we lost our moon because it's in a different position in the sky. So we'll go search for it again and we'll lock it on position. So if I hit the space bar, it should lock it now. Yeah, that's what I was missing before. And then we're just going to play this fast forward. So down at the bottom is our time buttons. And you can see this is coming in, and right there, a couple minutes back, we had first contact with the penumbra, right? And then if we, again, move forward through time, select the moon, hit the space bar, get it locked in the middle, right? And then let it forward through time. You can see it's crossing through the penumbra now and going back to the umbra. So that first contact on the western limb, back it up, but that would give you an idea for the contact that was out there. And again, I can back that up just a bit. Lock that in position and go back a few minutes. That was my first contact, or, you know, roughly within a minute or two. Your eye is going to be a better judge when you're looking through a telescope for that. We're going to pick a crater. We're going to look up here for the crater Plato. Was the one. You could look at Tycho down at the bottom, or Copernicus, or Kepler, or Grimaldi's over on the side. But these are all individual craters. If I turn on and let this fast forward, so I want to speed this up in time using the fast forward. You can see it's progressing across. We're getting closer, so we're going to slow it down a bit. And remember what I was saying about the kind of the terminator between the umbra and penumbra, that line? It's pretty fuzzy here. And I'm looking to see, you can see the progression that this is moving in. Starts first contact about 8 o'clock, and it moves up on the screen. There it's hit our target crater, so we hit stop, which is the play button. Went a little too far, but you get the idea. Gives you the time. And then if we just carry this on again, we're going to go a little faster. You can see we didn't hit quite totality, but now it's moving down and to the right on the moon. So in Randy's slides, it really didn't say, you know, kind of how the eclipse progressed. But let's play it back in reverse now. And take it back. You can see the progression, right? It comes in, it touches about 8 o'clock down here, moves up, moves across, and then starts to work its way back down. So I think I got rid of the space bar there. Any questions on that? So that was that's basically the quick walkthrough. The only other thing that we had to show was the flip buttons. So let's go back and find them.
That's it though, Al.
Yeah.
Al, we got to close it off now.
Okay.
So
we showed the flip buttons. You can test that for whatever you're seeing back on the screen. Okay,
so Rebecca is asking, how do you tell the middle of the shadow is with the naked eye? Not naked eye, the instrumented eye, with the telescope. And so you actually, in your question, you have the answer. It's the middle of that transition from penumbra to umbra. And it's not nearly as clear as you see in this stellarium simulation. And believe me, you get into debates with your observing partner. Is it there now? Is it there now? But the way that they would like you to call it is at that point when the light is changing most quickly from bright to dark. Okay, so it's that inflection point between when you're in penumbra and when you're in umbra. And it is a real value judgment. But
so
again,
it's fair to say the more data you have, the more those value judgments get ironed out.
Absolutely. Absolutely. And your first measurement is worse than your last measurement.
That's fair.
I would say when you have one, you have a piece of data. When you have two, you have an argument because which one is correct. And when you have three or more, then it starts to iron out, just like
and the goal to our dear colleagues across Canada is let's get lots of data. There was a guy named Byron Soulsby who in the 70s and 80s mobilized people in South Africa, Australia, New Zealand to do these observing campaigns. And they've had up to over, I think it was 1,200 observations in one of their eclipses. Are we going to get so many? I don't know.
But Sunny just has a quick question here, so I can address this. Are you making the observations until the maximum coverage when the umbra passes over the crater for the first time? After the maximum coverage, it'll pass the crater again, exiting. Are we not recording that? Record what you can.
Ingress and egress, one or the other. I have
or
never
both.
Actually, I've never actually had both.
Yeah, it's hard to capture them both. So Sunny, maybe you could do that. Use the form. There's the possibility of recording both of those, ingress and egress.
Event 2 is ingress, so going into the shadow, and 7 is coming out of the shadow into the bright.
Yeah.
Okay. Well, I just want to say a big thanks to Al and Randy and Kirsten for this lunch and learn, and to everyone who's been tuning in. Wishing you all stellar observations. Kirsten, did you want to say anything else?
Not at all. I just hope everybody gets to see it. Wherever I will be cloudy.
Oh,
let's hope it's not true for the rest of you.
Or smoky.
Or right? Smoky.
May you have clear skies when you're out looking.
Yeah, clear skies to everyone.
Take care, everyone, and hope to see you at the next Lunch and Learn.
Thank you, Randy.
Bye.
Thank you.
Thank you, Alan.
Bye.
Appreciate it.
Happy birthday, Sandhya. Happy birthday.
Happy birthday, Sandhya.